Greetings to all. So, discussing about the digital logic circuits. So, in the digital logic circuits, we have the codes. So, the codes are the understandable formats. So, when you have the numbers, so there are some rigid values, or it is going to be having a place values, but we cannot be able to have a other understandings. So, to have a proper understanding to within a group of people, we are trying to go for the codes. So, in the binary, and that we are trying to discuss about the binary codes. So, in the binary codes, we have the BCD, the binary coded decimal, and then we have XS3. So, BCD is going to be the binary coded decimal. So, it is going to be as a decimal value. So, you can able to see has the value to be available in the decimal. And when you try to go for XS3, we have a problem in the BCD. So, in the BCD, we have a, when you try to do the addition, we are supposed to check the answer whether it is going to be in the representable form, and then we are supposed to do the operation. So, that is going to be somewhat complex. So, to overcome that, we are trying to go for another code, that is going to be the XS3. So, this we have seen. So, this is for a representation which is understandable by the humans. For decimal, because humans are trying to always go under decimal, and binary is going to be for the computers. So, the understandable form between the human and computers, we have this BCD. In that, we have the problem. So, to overcome that, we have this XS3, and these two codes are there available. And when you try to go for the other code, gray code. So, this is going to be a non-weighted code. We have seen the classification already. So, this is coming under the weighted codes, and this is going to be coming under the non-weighted codes. So, in the non-weighted codes, we have the gray. So, each and every place there is not going to be any weightage available, but it is going to be for the understandable format. So, in the gray code, it is available in such a way that there is going to be only one bit change for a consecutive numbers. So, for the consecutive numbers, we have only one bit change. So, when you try to use this, it is going to be applied for counting, because when you want to count, we cannot be able to have more number of bit changes. So, we can able to just change one bit, and we can able to easily go for the counting. So, one of the codes available for a counting application is going to be the gray code, right. So, let us have the gray code. So, we need to have a comparison, or we are trying to check how the code is going to be available. So, we are trying to go for this binary value. So, how a binary value is available, for that how that code or a change is going to be made available as a gray code. So, this is going to be the gray code, and usually we have the decimal value. So, for the given decimal value, how it is going to be available for the binary and gray code, you can be able to see. So, in a given nibble, we can able to have representation for 0 to 15 or 16 representations. So, we are trying to see as this as a codes, we are trying to use in the nibble format, 4-bit gray code. So, in the binary representation, we are trying to have a nibble. So, this is a change. So, in the normally binary code, we have 2-bit changes. So, this is a consecutive number 1 and 2. In the two numbers, we have this consecutive numbers 2-bit changes available. So, we can able to have this as a weighted, binary is going to be weighted. So, for that we are trying to have this, but for understandable format to the counting value, we are needing only the 1-bit change. So we can able to have this binary. So we have this number of bits to be changing for the consecutive numbers. So in the gray code, we are trying to use only as a 1 bit change for the consecutive numbers. So this is going to be the consecutive numbers. So here you are trying to retain this and you are trying to change. So you can able to see this is 0, this is 1, but as per the weightage, when you try to compare this, this will be 3 and this will be 2. The next you are trying to have this. So we are trying to maintain this and we are trying to go for this combination. So the codes, so we have this. So this is 6, 7. That is, if you are trying to check with the weighted code. One minute. 110, and then we have this. So we have this conversion and then we try to go for this value when the bit changes. So we try to have this 1100, it is going to be 12. Then we have this bit change. Then we have as per the weights. So you can able to see this, and then we have So this is how we are trying to have this gray code. So you can able to have this change only in 1 bit when you try to compare in the consecutive numbers. So this is how we are trying to formulate the gray code. This is going to be the binary code or binary value, and this is going to be the gray code. This formulation is for counting application. You can able to have only 1 bit change. So when you try to check this 1 bit change, you can able to have this counting application 1, 2, 3, or it is going to be easily available as a counting process. That is why we are trying to frame the gray code like this. And when you try to have the weightage, actually gray code is a non-weighted code. So when you try to take the weight and check how it is going to be available, it is going to be available like this. So this is how we are trying to have this gray code. So now we try to check the code converter, or how to convert a given binary value to a gray code, right? So this is going to be a binary value and this is going to be the gray code value, and how to convert from binary to a gray code. Because usually binary is going to be available for counting application, we want to convert this. So we are trying to convert the given binary value to a gray code value. So the conversion process, let us have this labeling. For binary, we are trying to check this as this is start from this lower byte. So we are trying to take this as B0, B1, B2, and this is B3. For binary, we are trying to take this as representation. Similarly, for gray code, we are trying to take this label G1, G0, G1, G2, and G3. So if you want to find the values, so let us start from this G3. So if you want to find the value of G3, and when you try to compare this table or how this process is available, so you can able to see this B3 and G3 are going to be the same. So, you can able to have this B3 and G3 to be same. So, when you want to have the conversion, we are trying to get this G3 to be available as a B3 and the conversion process, right. So, the given value is B3, sorry, binary. So, we have the bits, binary bits B3, B2, B1 and B0. So, if you want to find the gray code, we are trying to have this as such. This is binary. So, if you want, we are trying to get this value just as such, we are trying to drop. So, if you want to find G2, we are trying to operate, use the operation XOR operation. So, we are trying to do the XOR operation between B3 and B2. So, when you try to do the XOR operation between the B3 and B2, we are trying to get this G2. And similarly, if you want B1, sorry, we want G1, it is going to be available as B2 XOR B1. That is the XOR operation from the given values. So, if you want gray code for the most significant bit, it is going to be just drop as such from binary. The next lower nibble is going to be the XOR operation between these two, MSB and the next consecutive number, and the next G1 is going to be the XOR operation between these two, and when you want G0, that is going to be the XOR operation between these two, B1 and B0, the LSB, right. So, let us take an example from this particular conversion, whether it is going to be correct or not. So, we are trying to get this value 4. Let us take a given value 4. Let us have the 4 as a binary value, and that is going to be converted to a gray code. If you want to convert this to a gray code, so we are supposed to drop the MSB. So, this is going to be the drop as such. MSB is going to be dropped, and if you want G3, it is going to be the XOR operation between these two. So, 0 XOR 1, it is going to be 1, and the next bit is going to be the XOR operation between these two values. So, 1 XOR 0 is going to be 1, and the next value is going to be the XOR operation between these two bits. So, when you try to take the XOR operation, so 0 XOR 0 is going to be 0. So, you can able to see the conversion is going to be using this logic. So, from conversion of binary to a gray code. So, we are trying to use this operation from the given binary digits or binary bits, we are trying to find this G0, and this is a answer available. So, this is going to be the method for converting a given binary value to a gray code representation, understandable format for the counting application. And the procedure actually, so this is going to be how we are trying to convert. This is by remembrance or how to get that value. Usually as a procedure, if you want to go for the code converters, we can able to go for the take the truth table and we can able to get the reduction using the K-map. So, let us check with that value. This is obtained. So, let us do the K-map simplification. Or simplification using K-map. So, so let us take for the G3. So, input is going to be 4 variables. So, we are trying to take the 4 variable K-map. So, the inputs are going to be B3 and B2, and this is B1, B0. So we have the 4 variable K-map. So in the 4 variable K-map, this is going to be the min term values for writing the given question. Where are the min terms available? So we can able to have for G3, we can able to see for G3, this is going to be first 8 values are 0 and then next 8 values are 1. So when you try to simplify, we are trying to group the adjacent ones and we are trying to go for the grouping of the maximum number of adjacent ones. So here we try to have this grouping, and for this grouping we have the answer to be available as B3. Hence we try to get this G3 is going to be equal to B3. And similarly we try to go for G2. K-map for G2 among the simplification methods, we have the K-map to be the pictorial representation on the simplest form for the simplification. So we are trying to use this and we are trying to copy this for G2. So if you try to take for the G2 for the given input binary values, we can able to have 0 0 0 0 and then we have 1 1 1 1 and then we have for 8 we try to have this as 1. So this is 1 1 and then last 4 is going to be 0. So when we want to group the maximum, so we cannot able to get a 6 nor 8, so we are trying to go for the 4 groupings. So adjacent ones, 4 adjacent ones are grouped and this is going to be B3, B3 bar, B2 and this is going to be B3, B2 bar. So your simplified answer is going to be B3 bar, B2 plus B3, B2 bar, and this is going to be the expression for the XOR gate. So this is going to be the XOR operation between B2 and B3. So this is how we are trying to get the answer. From this particular reduction, we have get this values B2 XOR B3. So similarly, we can able to go for G1. K-map simplification for the next bit, that is going to be G1. So for G1 we have 0 0 1 1 and then 0 0 1 1, then we have 1 1 1 0, then we have 0, 0, 1, 1, 0, 0. So here we had a 8 grouping, and here we have 4 grouping, and you don't have your 4. So this simplification, so we can able to identify that this is going to be available as a XOR operation between these two. So now we have the gray code. So if you have a gray code, how to convert to a binary value? Because once counted, we want to know about the answer for that particular value. So it can able to be counted on the system, it tries to use it only in the binary form. So we are trying to go for the conversion from gray code to the binary. So gray code to binary. So let us start with the K-map reduction itself. So given is gray code and needed is going to be the binary value. So we are trying to have the gray simplification again using the K-map. For the conversion from gray code to binary. So we are supposed to find for B3. So given will be gray, and for that we are trying to find the gray code. So we have this K-map. So this is the value. So this is 0, 1, 3, 2, 6, 7, 6, 7, wow. And this is V5. This is 4 and this is 12, 11, 13, 15, 14, 10, 11, 9, 8. So when you try to map, so we are trying to take this representation for that particular value. So we are supposed to fill this as a minterms. So let us take this value. So 0, 1, 2, 3. So this is all the values are 4. So 0, 1, 2, 3 are all zeros. Then we have 4, 5, 6, 7. So 4, 5, 6, 7 are 0. So it is going to be 4, 5, 6, 7 are 0. And then we have 12, 13, 14. 12, 13, 14, 15 to be 1s. So 12, 13, 14 and 15 are 1. And then we have 8, 9, 11, 12. So 8, 9, 11, 12 are 1s. So we are trying to have this grouping of more number of adjacent ones. So this is going to be 8 ones together, and this answer is going to be G3. So we have B3 is going to be equal to G3. Next, we are trying to go for the simplification for B2. So we try to have this K-map. So we are supposed to check with the input combination. Because this is minterms, we are trying to fill as a minterms. So minterms with respect to the given values. So this is going to be the next G2. So we have again 0, 1, 2, 3 are going to be 0. So 0, 1, 2, 3 are going to be 0, and then 4, 5, 6, 7 are 1. So 4, 5, 6, 7 are 1, and then we have 12, 13, 15, 14 are 1. 12, 13, 14, 15 are 1, and then we have 10, 11, 9, 8 to be 0. 8, 9, 10, 11 to be 0. So this is going to be the grouping. Of the values available, and this is going to be so we are trying to check this values. So these are zeros and these are ones, and here we have for this is going to be the input combination, so it is going to be 0 0 0. So we have 12, 13, 14, 15 to be 0, and then we have 8, 9, 10 to be 1. So when you try to group, you can able to have the grouping of this, and this is going to be G3 bar G2, and this is going to be G3 G2 bar. So B2 is going to be this combination of this G3 G2 plus G3 G2 bar, and that is going to be the XOR operation between G3 and G2, and this is the expression for the XOR gate G3 and G2. And similarly we are going for this K map for B1. So this is going to be B1. So we have B1 0 1 to be 0 0, and then we have for 3 and 2 we have 1 and 1. So that is 1 and 1, and then we have for this next it is going to be for 6 and 7 it is going to be 0 0. For 6 and 7 it is going to be 0 0, and then for 4 5 it is going to be 1 1. So we are trying to check this values, and for 12 13 it is going to be 0 0. For 12 13 it is going to be 0 0, and for 14 and 15 it is going to be 1 1. So here it is for B1. Next we have for 10 and 11 we have 0 0. So this is 10 and 11 0 0, and then for 8 and 9 we have 1 1. So the grouping, so we are trying to group here. This is going to be G3 bar G2 G1. This is going to be G3 bar G2 G1 bar, and this is going to be G3 G2 G1, and this is going to be G3 G2 bar G1 bar. So here we are trying to have the G1 to be common, here we have the G1 bar to be common. So for writing the answer we are trying to write in that particular form. So we are trying to take G3 G2 and G1 plus G3 G2 G1 plus G3 bar G2 G1 bar plus G3 G2 G1 bar. So let us take this G1 together or combine and rearrange. So we have the expression like this. and this is going to be the expression for G2 XOR G3. So this is G1, and here similarly this is going to be the XNOR operation of G2 G3, that is the XOR not a complement of the XOR operation, and this is going to be G1. And now when you try to compare this as a single variable, G2 or XOR G3 as a variable, this is going to be A not or A with our complement value and the complement value with the A. So this is going to be again the XOR operation. So we have this to be the XOR operation between G1, G2 and G3. So this is G3, B3, the most significant bit is going to be G3, B2 is going to be the XOR operation between G3 and G2, and for B1 it is going to be G1 XOR G2 plus XOR G3. So obtained gray code value, with that we are trying to convert. So when you try to take this conversion of this code converters, simplification method, we are trying to always use this K-map method. So this is how we are trying to convert from a given binary value to a gray code or a gray code to a binary value. So this is how we are trying to get the conversion. So the remaining topics can see later. Thank you.